We now discuss the solution of a problem from the section Trigonometry. The problem is related to the domain of a given inverse trigonometric function. This question has appeared in the joint entrance examination main held on 29th June 2022 in the first shift. The given problem is the domain of the function cos inverse of, in brackets, it's a quotient, the numerator is 2 sin inverse of, in brackets, 1 by 4x square minus 1 whole by the denominator pi is. We are given 4 options. These are the 4 options given here. Option A, option B, option C, option D. Required to find the domain of the function cos inverse of 2 sin inverse of 1 by 4x square minus 1 whole by pi is. We now discuss the solution of the problem in detail. And we want to find the domain of the function cos inverse of 2 sin inverse 1 by 4x square minus 1 by pi. And the domain of cos inverse lies between minus 1 to plus 1. Cos inverse of theta, then the theta lies between minus 1 to plus 1, including minus 1 and 1. This will be minus 1 less than or equal to 2 sin inverse of 1 by 4x square minus 1 by pi is less than or equal to 1. Multiply throughout by pi by 2. Then you will get minus pi by 2 less than or equal to sin inverse of 1 by 4x square minus 1 less than or equal to pi by 2. Because pi by 2 is positive and the inequality is maintained. Agreed. Now, since a sine function is a increasing function in the interval minus pi by 2 to plus pi by 2, so we take sine throughout the inequality. That is sine of minus pi by 2 less than or equal to 1 by 4x square minus 1 less than or equal to sine pi by 2, because sine theta is an increasing function in the closed and bounded interval minus pi by 2 to plus pi by 2. Agreed. Sine of minus pi by 2 is minus 1 less than or equal to 1 by 4x square minus 1 less than or equal to 1. This is the final, equality for this one. Agreed. We continue our discussion in the next slide. So this is what we have. Now we consider 2 branches. First is minus 1 less than or equal to 1 by 4x square minus 1 and 1 by 4x square minus 1 less than or equal to 1, this branch. So we consider 2 cases. Case 1 is this one, case 1. We take minus 1 less than or equal to 1 by 4x square minus 1. That will apply. Now, bring this minus 1 from left hand side to the right hand side. Then it will be 1 by 4x square minus 1 plus 1 greater than or equal to 0. Good. Take the LCM. This will be 1 plus 4x square minus 1 by 4x square minus 1 greater than or equal to 0. This will imply 4x square by 4x square minus 1 greater than or equal to 0. So cancelling 4 throughout, you will get x square by 2x plus 1 into 2x minus 1. Those are the factors for the denominator greater than or equal to 0. Now, this is greater than or equal to 0 provided the numerator is equal to 0. That is x square is equal to 0. That is x is equal to 0 or 1 by 2x plus 1 into 2x minus 1 is greater than 0. It's either is equal to 0 or this one is 0. So we have taken out x square. Why? Because x square is always positive and it is 0 when x is equal to 0. So that is why we have written x is equal to 0 r 1 by x plus 1 by 2 into x minus 1 by 2 greater than 0. So what is the solution set for that? So the critical points are minus 1 by 2 and plus 1 by 2. That is the division of the real numbered line. Agreed. Now we test its positivity, its sign greater than 0 or less than 0 in the interval 1 by 2 to infinity, 1 by 2 to infinity. And you can see if you take any x in the interval 1 by 2 to plus infinity, then this will be positive. So it's positive, then it will be negative, then it is positive. Therefore, we can write its solution set now. So this will imply x is equal to 0 or x belongs to this one, positive sign minus infinity to minus 1 by 2 open interval, union, and you leave this, and the interval, open interval 1 by 2 to infinity. That means write it in a set theory notation as a union. That is x belongs to the open interval minus infinity to minus 1 by 2 union, the open interval 1 by 2 to infinity union this singleton set 0 because of x is equal to 0. So call this as the relation 1. Agreed. We go to the second branch. So that's what we have done so far. Agreed. Now take the second branch. So to second, we take 1 by 4x square minus 1 less than or equal to 1. So 1 by 4x square minus 1 minus 1 less than or equal to 0. Take the LCM. That is 1 minus 4x square plus 1 the numerator by 4x square minus 1. And that will imply 1 plus 1, 2 minus 4x square by 4x square minus 1. So you cancel minus 2 throughout. Minus 2 throughout in the numerator. You take the minus 2 common and cancel. Then the less than or equal to will be get reversed, greater than or equal to. Right. So 2x square minus 1 by 2x plus 1 into 2x minus 1. And 2x square minus 1, this we have written as x plus 1 by root 2 into x minus 1 by root 2. That means we have cancelled 4. And here also 4 we have taken common, and x plus half into x minus half greater than or equal to 0. So that's we get the 4 critical points. Write down the critical points in the order, in the increasing order. And that is minus 1 by root 2 and minus 1 by 2 and 1 by 2 infinity. So minus infinity, minus 1 by root 2, minus 1 by 2, 1 by 2, 1 by root 2 infinity. Right? These critical points in the increasing order. Now take the extreme right interval, that means the open interval, and now this is greater than or equal to 0. Is equal to 0 is also included. That is equal to 0 is when x is equal to minus 1 by root 2 and x is equal to plus 1 by root 2. So they are included. In the extreme right interval 1 by root 2 to infinity, this given one is positive. So positive, then negative, then positive, then negative, then positive. So that's what you get it. Agreed. Therefore, so x belongs to, this will imply x belongs to minus infinity to minus 1 by root 2, and leave this one. And this is the open interval minus 1 by 2 to plus 1 by 2. So in this minus infinity to minus 1 by root 2, it is semi-closed, at minus 1 by root 2 end. And this you have to include the open interval minus 1 by 2 to plus 1 by 2, leave this, and this is 1 by root 2 to infinity, closed at 1 by root 2 end. So that will be x belongs to minus infinity to minus 1 by root 2, this one, and the union, the open interval minus 1 by 2 to plus 1 by 2, union 1 by root 2 to infinity, closed at 1 by root 2 end. This is the second one. Then you have to you have to consider the end. End means the intersection of these two. The intersection of these two will be the domain. So, taking the intersection of 1 and 2, we get the required domain. Now one may say, you have to draw the real numbered line, and you write down this one and write down this one, take the intersection. So in all these things, while intersecting this and this, the red one, minus infinity to minus 1 by 2, minus infinity to 1 by root 2, that there only the commonality is there. If you take the intersection, the smaller of these two, that is minus infinity to minus 1 by root 2 will be there. And the remaining ones have nothing to do, because their intersection is empty. And the blue one, 1 by 2 to infinity, here 1 by root 2 to infinity, the smaller of these two, these two is 1 by root 2 to infinity. And this green one, open interval minus 1 by 2 to 1 by 2, 0, the common 0 element alone. So therefore, the required domain is minus infinity to minus 1 by root 2 union 1 by root 2 to infinity union 0 element alone. So that is the required domain for this example. So the answer is option D. So that is the detailed discussion of the solution of the problem from the section trigonometry, and the question is related to the domain of a given inverse trigonometric function. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.